Um, our project is on the fundamental theorem of calculus, integrals, and Riemann sums. My name is Xavier Odom,
And I'm Philip Adams.
and we are the Roger A. Young Group.
Who is Roger A. Young? Roger Arlena Young was the first African-American woman to earn her PhD in zoology. Young enrolled at Howard University at the age of 27. She started out as a music major, but later switched to biology. She earned her bachelor's in science in 1923 and was hired as an assistant professor while attending graduate school. She then earned her master's of science in zoology in 1926. Young was also accepted into the University of Pennsylvania and completed her PhD in 1940.
Here's a little bit of background. An integral in mathematics is either a numerical value to the area under the graph of a function for some interval or a new function, the derivative of which the original function is determined as the indefinite integral. Riemann sums is named after the German mathematician George Friedrich Bernhard Riemann. Riemann sums is used to find the approximation of an integral. And Riemann sums also help us approximate definite integrals. Furthermore, they also help us formally define definite integrals.
So the nuances and pitfalls. Definitely whenever you're solving these problems, you always want to remember to use the integral sign. You always want to remember to do the integral and not the derivative. And also when you're finding your du, always remember to include dx or d and whatever the variable may be used. An example, if your problem has dt, then you're going to always remember to put dt. If it's v, dv, etc. Also, always remember to plug in the given upper limit and the lower limit to find your new upper and lower limit.
Here is an example of Riemann sums and integrals using to find the limit. As the integral a to b and function f of x dx equals the limit n approaches infinity, sigma n I equals 1, the function that we have f a plus delta xi is equal to the height of the function. And the width is also equal to delta x. Basically, we're going to find the sum of the area of rectangles. That's what Riemann sums are used for. As the limit of n approaches infinity, sigma n I equals 1, ln 2 plus 5i over n times 5n, or 5 over n, is the problem that we'll be working on today. If I is equal to anything, you will multiply the width by the width. And in this case, the width is delta x. Our function f of x is equal to ln x, as you see in red. And our lower limit, which is 2, our a is going to be equal to 2. And our delta x is equal to 5 over n. As the integral 2 ln x dx is our function, we need to find the upper limit. So to find the upper limit, you have to use delta x equals b minus a over n. Delta x is equal to 5 over n, so that's what we're going to be using, and equal it to b minus 2 over n. In this case, b is equal to 7 because 7 minus 2 is equal to 5. So for our final function, as the integral 7 are 2 and 7 ln x dx will be the final answer.
All right, so now we have our real world application. So the problem reads as following. The population of a town grows at a rate of R of t plus R of t equals 300 times e to the power of 0.3 t people per year, where t is time in years. At time t equals 2, the town's population is 1,200 people. What is the town's population at t equals 7? So here, if you look to your right, you see the problem right here. So we're gonna put 1,200 plus the integral of 2 to 7 of 300 times e to the 0.3 t. If you're wondering where I got a 1,200 from, that's because t equals 2. And when t equals 2, we have 1,200 people. So we're gonna start with u substitution. And when you're doing that, you always wanna look for what's stuck inside. So if you're looking closely, you see e to the 0.3 t. So u equals 0.3 t. Now we're gonna take the integral of that, and then we end up getting du is equal to 0.3 dt. But we need to get rid of that 0.3 dt. So we're gonna do the same on both sides. We're gonna do 0.3 over 0.3, which cancels that out. And we're gonna do du over 0.3. And then you have your new problem, which is 1 over 0.3 du is equal to dt. But before we move any further, we need to find our new upper and lower limit. So when t is equal to 7, we're going to have u, which is 0.3 times 7, and you get 2.1. And when t is equal to 2, we're going to do u, which is 0.3 times 2, which is equal to 0.6. So now we move the 300 over, and we have 300 with the integral of 0.6 to 2.1 of e to the u with du with 1 over 0.3. So then we need to move over the 1 over 0.3 with the 300. So now we have 300 times 1 over 0.3 with the integral of 0.6 to 1 of e to the u times du. And that equals, when we multiply the 300 times the 1 over 0.3, 1,000. So now you have 1,000 to the integral of 0.6 to 2.1 with eu and times du. So now we have 1,000 e to the u, and we have our vertical line now because we have 0.6 to the 2.1, and now we need to find out the values for both of those. So we're gonna multiply it now. So we have it's equal to 1,000 in brackets e to the 2.1 minus e to the 0.6. And that's also equal to 1,000 e to the 2.1 minus 1,000 e to the 0.6. And when you do that, you get 6,344.05, but you can't have 0.05 people. So we're going to estimate that. And now we have 6,344. So now we're going to bring down back to 1,200 plus. And when we add that up, we get 1,200 plus 6,344, and you get 7,544. So when t is equal to 7, the town's population is 7,544 people. Thank you.
Is that the end?